Uh,
A very good afternoon to everyone. We welcome you all to the 3 days basic astronomy code camp. This program was scheduled earlier in February with Dr. Ratnashri ma'am, but due to her sudden demise, we are rescheduling this program on 3 days, that is 22nd, 23rd, and 24th from 2 to 4 p.m. So today we'll be discussing the basic Python in coding. To discuss more about that, we have Saurabh, who will be the mentor for today with us. Saurabh?
yeah. Hello, ma'am.
Yeah.
Thank
Hello.
you so much for
So, yeah,
introducing.
Saurabh is a space enthusiast and he has a long association with Nehru Planetarium on various projects with Dr. Ratnashri ma'am. Even today, he's also helping us in many other ongoing programs. So today we'll be starting our code camp for 3 days. So over to you, Saurabh. Day one, Saurabh will be taking. Tomorrow we have one more guest with us. Will be joining for the second day, and third day we'll be having the detail whatever we have learned in day one and day two. So we'll try to have a 3 day coding, the basic for the beginners in Astronomy Code Camp. So over to you, Saurabh. You can go ahead with the program.
Okay. Thank you so much, ma'am, for introducing. So, just a second. Okay. So I think I am audible, right? So whoever is right now attending this uh, live stream, just type in the comment box that you are currently able to hear my voice very smoothly and there is no interruption. If there is any, please comment it right now, and then I guess we can move on to this first day of the Astronomy Code Camp organized by the Nehru Planetarium. So those who are there, please just let me know. Uh, I am not seeing any comments. I guess I am able to. I guess my voice is quite audible to everyone. Okay. Okay, it is audible. Okay, thank you. How long is the code camp? It's almost for it's 3 day camp, 22nd, 23rd, and 24th of June. So 3 days. This will camp will be going on, and for the first day today, I'll be introducing basics of Python, as we all know that, or if anyone of you has ever attended this camp before, organized by Planetarium. What we do is in the first day we first try to understand the basics of Python and its basic applications uh, in the field of astronomy and astrophysics and cosmology. So Python is one of the programming languages that is currently being used all over the world by esteemed astrophysicists, researchers, and physicists, and all kinds of people who are into programming and coding. So today we'll be going just through the very basics of understanding how things actually go on in the field of programming. So right now we'll be starting with Jupyter Notebook. So Jupyter Notebook is actually a sort of very basic environment as to in which you want to work on. I'm not seeing any comments. I guess I'm able to. Okay. So just I think there's some issue with this. Just hold on for a minute. Okay, so yeah, now it's better. There's some reverberations of my voice which is going on, so it has been handled. Okay, so now we'll be working on Jupyter Notebook for those who are unaware of what exactly is Jupyter Notebook. So Jupyter Notebook is kind of an environment to work on Python. Now you can consider it like this, like suppose you live in a home, right? And there are different rooms. So if you want to study, you can study in any particular room, right? You can either study in your bedroom, you can study in your study room, or there's a drawing room. You can study in any particular room, but it's totally up to your choice. So Jupyter Notebook is kind of similar like that. Like what sort of uh, work you want to do, and on that basis we choose Jupyter Notebook. So Jupyter Notebook is kind of a very basic and very who is actually beginning in this particular Python or in programming domain can actually grasp the knowledge very easily and is able to work on this. So this is Jupyter Notebook. Now, for those who are not able to who does not have this Jupyter Notebook installed, I think you can basically try to open an online Jupyter Notebook, which is again facing some issues. Okay, so yeah, you can join an online Jupyter Notebook. I'll quickly send a link for that. I think that might be appropriate. So you just have to type Jupyter Notebook on. Okay, apologies. I think there was some issue with my connection. Okay, now it seems fine. Okay, kind of apologies for that mistakes, that there are some issues. Now what you have to do is you have to go to jupyter.org and open this particular link, which is jupyter.org/try. And there is this, you'll see this kind of interface. You just have to go try classic notebook. So once you click on this try classic notebook, you will see there is some interface which is quite similar to what I just showed to you, like the Jupyter Notebook. Just give it a while and it will start up. Now, for those who are currently attending this session, try to try to work as I try to go on. Even they can try to match up. I'll take a pace at which everyone is quite comfortable with. So I hope I'm not going too fast into this. So you just have to wait for a while and it'll open a Jupyter Notebook for you. Okay, maybe there's some sort of internet connectivity issue with me, which is taking a lot of time while starting. So what you can do is you can simply click on this link and you will have something interface like this. Maybe not this particular thing, but something like this. And This is what we say as Jupyter Notebook. Here, what you can do is you can change the name of your file. I mean, just for the starters, like right now it's titled as Untitled 3. You can let's say basic Python introduction, and name your file like this. So this is the very first step in naming your Jupyter Notebook file. Now here, what we have is these things which are numbered and written within. This is actually the input cell that we say. So there is this one cell where you actually write the whole code, and then you try to run this code by pressing Shift plus Enter. So whenever you have to compile a code or compile a particular cell, what you have to do is you have to type in some code and then just press Shift plus Enter. So you have to Shift plus Enter it. Okay, I'm just writing it for those who are who might see it later on. So Shift plus Enter, and then that code will run. Now, the very basic use of this Jupyter Notebook is this interface. It actually acts like as a calculator. So let's say I want to use this as a calculator. Now I want to do some basic computations. Let's say 76 plus 3, right? Now, if I want to run this code, this is the input cell. I just have to press Shift plus Enter, and this code will run. Right. So right now, what you see is this is the input which I gave, which is 76 plus 3, and this is the output which it shows us, which is 79 in the form of an external output. Right. So this is the very first step in which in invoking Python, invoking Jupyter Notebook, where it acts as a basic calculator or basic computations. Now let's say if you have some basic stuff basic things which you want to compute, like let's say some complicated equations, let's say 8 plus 10, and then you add some brackets, BODMAS rule basically. 8 plus 10 into 3 into 2 minus 50, like say this number, divided by some particular thing, this whole. Now I added some brackets. As you can see, I want to divide this whole number by some particular, let's say, number. So this is looking sort of a complicated equation. So what I need to do is I just simply need to press Shift plus Enter, and it will give me an output in terms of decimal points, right? So here we have this 12 or 15-digit long, I suppose, output of this particular number. Now in Python, it's actually necessary to understand that what type of numbers or what type of data you are actually handling with, right? Now in Python or in any programming languages, be it C, C++, be it Fortran, or be it Java, there are these certain type of data types which you need to understand, such as integers, floats, strings, or there's some libraries and there's some different types of data types which you can input in programming languages. Now, for example, when we say integers, so integers are basically numbers which does not have any decimal places, right? So if you see here, what I input here is 76 plus 3. Now 76 is an integer and 3 is an integer. So as a result, I will get an integer, right? Because addition is a simple addition. Now here, if I see, I have given up all integers, but when I divide it, it actually converts it into decimal points. Now, whenever we are trying to understand a number which has some decimal points in terms of programming language, we call it float numbers, right? So we have int, which stands for integers, and then we have float, which stands for decimal numbers. Okay, in simple terms, it's basically decimal numbers, right? So as you see here, whenever I write some code or any sort of thing, this certain words or certain phrases actually highlight themselves, right? So here you see int is highlighted in green and float is also highlighted in green. So these phrases which are highlighted, these are actually inbuilt small functions, as you say, of the Python which is pre-installed and which comes with Python as well. And these certain functions, these certain small phrases, these actually help us to convert from one data type to another data type, right? Now, int and float, these are related to numbers, right? These are related to numerics. Now, in terms of characters, if you input some, characters such as my name is Saurabh, or my name is this, or any sort of string alphabets or anything like that, we say it as string, right? So here in Python, the string has a certain phrase which is str, and this stands for strings. Right now, I'll show you the basic use of these three data types, which are quite important in terms of computation and application base. So let's say I have a certain number. Let's pick up a random number. Let's say 75.5. Right now, as you see, 75.5 is not an integer; it is a decimal number, right? So in terms of Python, it is basically a float number. Now I want to convert this float number into an integer, right? Now what I'll do is simply I'll do int and I'll do this. Now let's see exactly is the output, and on that basis of output, whether it shows any error or whether it shows any sort of number, it's up to us to interpret what exactly does this, but does that mean. Now here as I input, it says 75.5 is actually taken as integer as 75. And whenever you have to input, so in terms of programming languages, whenever you have to give some command, so that particular command has this called thing called argument. So argument is basically what is the input you supply to this particular piece of code, right? So whenever you have to give an argument, it is always into this parentheses, or what we say as brackets. Okay, simple brackets, curved brackets. So whenever I give some argument, it is basically in curly brackets. Now, many different functions in this Python. Those functions, these are simple functions. As you say, in mathematics you have functions. So these are similar to that, but much more easier and in a simplified way. So here, if you say like I have this int 75.5 and I converted it into an integer, okay, I converted a float number into an integer. So here it simply returned it as an integer. Now, if I do it 75.7, it will always return me to the initial integer number whenever I have a float number, right? And whenever I have, let's say, an integer number and I want to convert it into a integer. I have a integer number. I want to convert it into a float. So what I'll do is I'll simply do the float command, and into the argument I'll give an integer. Let's say 6. It's interesting to know that how I can convert an integer to a float. So in simple terms, it's simply a dot o. Right? There is simple 6.0. Now this is the way in which you convert from one data type to another data type, or let's say integer to float or float to integers. Now, many of you might say that, "Oh, what exactly is the necessity, or what's the importance of this data types, this integer, this float?" So it turns out that whenever you're trying to do some complex stuff, and in these computations in astrophysics or even in physics or in mathematics, certain functions or certain things takes a certain type of input, which means that they either work on integers only, they either work on decimal points, or let's say they work on whole numbers, right? So those whole numbers here, which we say as integers, are let's say very essential to that. So for that particular function, for that particular purpose, we need integers, and for certain things we need decimal points. So that's why we have float. So that's why we use different types of data types in different uh, uh, usages, right? It depends on the user as to how that particular person wants to use it, right? So this is the very basic step into coming from the programming world, right? Now I actually skipped a very small point, and which is considered as to be a very important and sort of convention whenever you step into programming, is printing the hello world command. So now first let's do that, right? So how do you print this hello world command? So what you have to do is you simply have to type the command, which is print. Just have to write print, and then argument it takes in curly in brackets. And whenever you want to print something in, and I'm saying hello world, so hello world is basically a string, right? It's set of alphabets. So whenever you have to write some set of alphabets and you want to print them as alphabets, so you have to basically type them into commas, right? Into quotes, into inverted commas. So here I'll give it an inverted commas and I write hello world. So here we have hello world. And this is the very basic This is the very basic command that normally every programming user when step into any new language does. It is to understand the print function. So print function is quite important whenever you want to let's say understand like what exactly is the output of my particular program, or or let's say whenever I want to debug my code, right? Debugging is basically you want to see if your programming is actually working according to what you want it to, right? So that is debugging. So sometimes it helps a lot in debugging the code as well, and also printing the output as per you just want to see exactly what type of output this particular function is giving to. So this is how we do basic printing. Hello world. Now, so there are different functions as well, inbuilt functions of Python, and I don't want to rush it, but I think maybe for those who are into college level, or those who are high school, or into an 11th or 12th grades, maybe they can term it easily. So here, this was uh, this was the basic introduction as to Python. So at this point, I would like to take a stop for a minute and want to ask if there are any questions still now, or if there is anything that anyone wants to ask. So they can simply just put in the comment box and answer and question and put up their question if there is any. So I see there are a couple of questions which says, what are the prerequisites? Okay, so for prerequisites for Python, I don't think that there are not as such prerequisites, but yeah, for programming, I mean, if you have some background in C++, okay, that would be better. But if you're very new to programming, so I don't think there needs to be any prerequisite. Like, it also depends on what purpose you are actually, what sort of purpose you have for using that particular programming language. So even that's dependable, but right now for understanding Python, really don't need any sort of thing to understand right now. But yeah, as we'll progress further, tomorrow and day after tomorrow, you'll be learning some advanced stuff, such as basic curve fitting and basic understanding of Fourier transforms, and then converting different units, and and all sort of different amazing stuff that we'll be doing in final day, which is analysis of a pulsar data set. So we have this pulsar, a very compact neutron star, rapidly spinning around, and we'll be analyzing a data set which we receive from radio telescope, and we'll be doing that on the third day. So yeah, for that, obviously you need some understanding of basic Fourier transforms in theory, and some basic physics. So yeah, for that, what are the basics for astronomy coding? Yeah, I think what I said covers up as well. So for astronomy coding, obviously, if you want to code some astronomy uh, for your work, you obviously need to know the astronomy, the physics behind your code, and I mean, you can start from scratch. Uh, there's no threshold as to where you will reach, or where the minimum criteria. But if you have some basic understanding of physics, some basic maths, you already know that, which is high school mathematics, that actually helps a lot. So maybe I think that would be more than enough to actually go on and understand this basic stuff. So I think that would be it. So okay, maybe any more questions? Any else? I don't see any, although. Okay. Okay, I think we'll go on with the today's session, and progress further. So right now, this was all about understanding basic Jupyter Notebook, acting this thing as a calculator, understanding basic data types. So yeah, I forgot to mention one thing. So if you want to convert a data type, let's say string. So for string, what you can do is you can simply do str and put this thing. Now it's interesting to note that you can convert from one data type to another data type. But what if I'm trying to convert a string to an integer or into a float data type, right? So let's see how this actually works out. So let's say I input some string into the str code, and let's say I'm just writing hello, right? Now, obviously, that was quite expected because the argument that we had was already a string, right? And I converted it into str, which is string, and it obviously gave me a string as an output. Now let's see if I have some integer. So let's say I have some integer, let's say 3 or let's say 4. Let's see what's the output of this. So it converted an output with inverted commas, right? So here you see here is a small change here. So what's actually happening here is this string uh, command, it actually changed the data type of of this particular number to string format. And how we know that is basically we see that in the output there it is enclosed by these inverted commas, right? So these inverted commas tell us that it is basically enclosed, and this is basically a string, right? And when we when we do not see any sort of inverted commas here in the output, it's not a string, it's a number, right? So this was the first step into understanding data types and converting them. You can try to play with this thing as you progress, or if you want to play with it, you can even do it right now. So you can do, let's say, 4.6. It converted a 4.6 to string as well. Now, what's interesting to note here, now let's try to convert a string into an integer or float, right? Let's say I convert hello. Okay, so now here it actually showed me an error. Now, in programming language, and this is actually a very first, the very important point which you should note. And if you're writing some notes there, we should mark it as triple V or 4 times VIP. It is very, very, very important. Is to understand the errors which you get in Python or in in any programming languages. Understanding error will actually help you a lot, because many a time what will happen that you will try to code something and you are not able to understand what exactly is happening in my code, and it will not be according to what you want it to be, and then suddenly it will show some error. Now if you do not understand the error, you will not be able to solve it. So it's very important that you understand what sort of error you're getting. And whenever you, so it's like mathematics, right? You will understand it only by practicing. So you have to practice a lot, you have to gain experience in coding and programming, so that you are able to understand what sort of error I'm getting. Now here it showed me it's a value error type, right? So there are different types of errors in Python. So one of this is, it says it's a value error, which it says that invalid literal for int with base 10 hello world. Now what this means is that int, it takes a specific type of input as an argument, right? So it actually takes as just integer or float. Okay, only do these type of things. Now here what we supplied here is we supplied a string. Now how can we convert a string to a number? That's the main thing. We cannot, right? So that's why what it showed me as an error is invalid literal. It's an invalid type of literal which I gave, invalid type of input. Hence it will not it will not work. Now if I write it, let's say some particular number, and voila, we do not have any errors, right? So this is how we understand any errors. Now let's say I can do the same thing with float as well. Float, and just write, let's say, Star Wars, right? Again, it showed me the same error. It says to not convert string to float Star Wars. Now this showed exactly the same thing here. The error was a bit different compared to here, but although it was the same thing, which is the value error, is that the type of input which I gave, the type of value I gave to the function, to that particular argument, it's actually not correct. So it says cannot convert string to float. So here it cannot convert a string into a float. So that's how you understand it. So whenever you're trying to understand a function, or whenever you're trying to understand a particular code that you are writing, you need to understand, if I'm having some error, how will I be able to solve that thing? So for this you have to understand the type of error you are getting, right? So in Duke we'll also try to understand, uh, will be facing many issues as in we'll do some error based things as well, that will be having some errors, and then we'll see how things go, right? So this was the first part of this whole thing. Any questions if till now? So don't hesitate to put up any questions. If you have anything, just put them in the comment box, and I'll try to reach out and in between as well. So it will be like a two-way thing, not just me speaking all the way around, right? So there should be some sort of participation with you guys as well. So if you are having some questions, just simply put them in the comment box. I'll get back to you as soon as possible. So right now, as I see that there are no queries or anything, so until now it's going on smoothly, I suppose. So maybe I can go on, I guess. Okay. Also, there's around 10 to 15-second lag uh, between my streaming and going on live. So even in that's a bit inconvenient, but we cannot help that. So you might have to bear for that. All right. Okay, so I suppose there are no further questions. Maybe we should go on. Okay, so now here what we see is okay. So now we'll move on to the further chapter, which is understanding how to assign values to particular variables, or how to assign some particular things to particular. Uh, uh, let's say we have some numbers. I want to associate it to some particular variable name, or let's say I have some string letters which I want to put this thing into this particular variable. So this is what we say is assigning a value to a variable, which is actually quite important here, because in Python, or in general in programming, uh, the basic mathematical symbols seems a bit different in terms of understanding. Now here's this very important thing. Now sometimes what we see is when we try this equals to sign, right? So equals to, in mathematics we say that this, let's say x equals to 5. Now here what we mean is this x is actually equal to 5. This x holds the intrinsic value of 5. Now in Python, what happens is when we say x, let's say x equals to 5. Now what I'm doing is I'm assigning a value to this particular number, which is 5. So now whenever I will be using this particular variable, which is x, in all of my coding, or in all of my functions, or anywhere, it will hold this particular value 5. So I won't have to every time type 5. I'll just have to type this x and do on something like this, right? So let's say I have x, and let's make it a bit clean. Or maybe not. I think I shouldn't have done that. I'll just undo it, because maybe someone else might need this file. Okay, quite apologies. I'm taking a bit time, but okay. So okay, let's say I have assigned some value to x equals to 5. Let's say I have y equals to 10, right? Let's say y equals to 10. And let's do a simple addition. Oh, I haven't run this particular cell. Now it's important that it's imperative that you understand that whenever this particular cell has run or not. So whenever you run this cell, you will see a number assigned to it as well, to the cell, right, which is, let's say, in 15, which means this is the 15th time I have run any particular cell, right? This shows me a number. Now x equals to 5 assigned, then I have assigned y equals to 10. Let's do a simple math, which is x plus y. Now, I don't think I need to ask this, but x plus y is obviously going to be 15. So here we have the answer, which is 15. Right? It's quite simple, it's quite easy, and very easy to understand. Let's make it a bit different. Let's say I assign another variable to this particular number, which is z is equal to x plus y. And here we have x plus y. Now, what it is, x z equal, what's the value of z? Now, I just have to put z, and I can, take the value, whatever it is, which is 5. Or what you can do is, if you want to see what exactly this z holds on to that particular value, you just have to type in print and put it into this uh, parenthesis. Now here, if you see that here earlier we used this this literals, this inverted commas to output this string letters. Right now here what we have is a variable, right? I do not want the output as z, z as in the alphabet, but I want the value which z is holding on to, right? So here I just have to put in parentheses and I'll just put in z, and here I'll have print z, which terms that's 50, right? So here we see that this is an important function, this print function, which is quite important as to understand, what exactly this particular variable or what this function actually holds on. So here we have done some very simple things, right? You can do some complex stuff. Let's say x is equals to 5. Now, if you want to do a square, right, square of some particular number, so whenever you have to multiply, you use 5 into 5. So you have to use this star, or let's say asterisk. Okay, the term which we say, it is an asterisk. Now, if you want to make it power of something, let's say I want to raise 2 raised to the power 2, so I have to use double asterisk, right? So 2 raised to the power 2. Now here x is equals to 2 raised to the power 2, right? So if I print the value of x, what will I have? It will be 4. And here we have 4, right? Quite simple. If right. So yeah, raise any a number. Let's say 2 raised to the power 32, right? This seems quite easy. Let's say x equals to this particular number, right? So it's a quite long number, right? I mean, it totally depends on what sort of complexities you want to introduce in this particular thing, or what sort of simplicities you want to introduce. It depends on the user. It depends on what type of work that user wants to do. So you can complicate this at a level whatever you want to. So right now we are dealing with very simple things. After that, we'll so if you have some time, you can try to make a function. Let's say if you're a physics student, you can try to make it a function of you can try to put in the values like Planck's law or something like that, right? Putting the value of temperature, putting the value of frequency, exponential and stuff. So right, we'll be coming to those mathematical function as to how to do that just after this thing. So I hope there's no issues with this. Now, let's do some simple things. Y equals to 43 times 4 divided by 2 minus some number, let's say times some number, let's say minus some number, which says some number, let's say 12, something like that. This thing that ain't too large to convert to float. Now here it's what it's saying, that the number is very large. Now obviously I raised a 4-digit number to a 4-digit number. Now this number is going to be quite long. So every programming language has this internal memory of a sort of a thing, which it can hold on to. And I actually do not remember what's the limit of this Python, but it's obviously limited, right? So it actually sort of exceeds sometimes, and it's saying that it's too large to convert. Now I just have to reduce it. Reduce. Now let's say I introduce another variable. Let's say x times x minus y times y. Let's say I want to make a square root, right? Square root. Now for those who know this, and I hope everyone knows it, square root is nothing but raised to the power of half. Let's say raised to the power of 1 by 2. So we'll just raise this to the power of 1 over 2, which is 1 divided by 2. And in the brackets, mind you, you have to use the brackets. You have to always keep in mind that this uses the BODMAS rule. BODMAS is, right, I hope everyone is quite clear with the BODMAS rule. So they use BODMAS rule, and we have to keep a track of all the brackets and, you know, parentheses and all sort of things. And every time have to use those square brackets or curly brackets at all. You only have to use parentheses, you know, in these mathematical calculations. So either you can type 1 by 2, or you can even do 0.5. It's one and the same thing. Now it's taking some time to do that. As it can be seen here, you see here is a star, which means the program is still running. And I'm guessing this will take a whole lot of time, because I'm raising something to the power of something, which is eventually quite a big number. So maybe let's just stop it for the sake of understanding, and let's make it, let's make it right in. Okay, that's relatively faster. Now we'll just do z. Let's say print z rather. That would be much intuitive. Print z, and here we have this number. You see this particular number. It's, I don't know if you're able to understand this or not. This is basically an imaginary number. Now what we understand by this is that somewhere, how this particular number is imaginary, let's say. So here you see this is the first real number, which is this 1.377 times e plus 96. Now what does this thing mean? So e plus 96 means that this particular number multiplied by 10 raised to the power 96, right? This is what this first term means. So whenever you see e, then after that some particular number, which means that 10 raised to the power that particular number. If it was written e minus 2, which would mean 10 raised to the power minus 2, right? Now this was the first term, plus this was the second term, and here see it is e raised to the power of 112, which means 10 raised to the power 112, and it times j. Now in Python we in mathematics we normally denote an imaginary number as iota, right, as an I. So here it uses j. So here it is a imaginary number, right, which means that somewhere in between there must be a negative number, which was not able to, you know, find something uh, you know, in the real domain. So this is an imaginary number. Now okay, now there's another thing which I think I forgot, which are, you know, real and complex data types. Now even we have those data types in Python as well. Now let's say I want to let's say okay, let's say I want to make a data type into a complex data type. Let's say I want to make 10 in the complex term. So I have to do nothing. I have to simply type complex and put it into the bracket, right? Complex, and the argument as 10. And it converted my number into a complex number, which is 10 plus 0 times j, which is quite understandable because there is no imaginary part involved, hence 0j, which is 0 iota in mathematical terms. Right, so this is my number. I can assign some variable to this particular number. Let's say a, or let's say let's be some you know, let's play out something else. Written as name error. Now, whenever you see a name error, it means that there is some issue with a function or with a thing which has not been defined before. Okay, this is something which you haven't defined yet. So here is say that name comple. Now here it is written comple is not defined, which means that I haven't put my okay. So there were some issues. Okay, so here it means that this particular it's all right. So here we see that this particular command I haven't, there's some spelling mistake, so I have to correct it, which is X, which is quite understandable because these inbuilt phrases, these inbuilt commands have their own, highlighting their terms, so it wasn't highlighted. So here I have this thing. Now, as you understand, I can add up those numbers. So I will take Captain Cook. So let's assign some another number. Let's say enterprise. Enterprise is equals to Captain Cook plus Spock, and I'm adding few more cells. And let's see what's the value of enterprise, right? Enterprise, right? Which is 55 plus 0j. Which is quite understandable. Why? Because there's no imaginary part. That's why it's saying this. Now I can introduce some imaginary part. So what you have to do is you have to do nothing. You have to do plus. Whenever you have to write some number, let's say I have to write 10 plus 6 iota, or this is 6j. So you have to just do 6j, nothing else. And same goes here. If you want to introduce something, let's say 50 times, like 50 times, which is 50e7, which means 50 into 10 raised to the power 7 times j. So here I have created two different complex numbers. Now here it's not necessary that I have to write this complex thing, because I no longer require them to be complex forcefully, because they are by definition they are already imaginary. So I just have to do this thing, run these cells again, shift plus enter, run these cells again. And here we have finally the correct answer, which is 55 minus 49 something, right? So that's our thing. Now yeah, so it's so addition and subtraction it's quite different. So you have to see for that the answer is correct or not. So you have to check it manually as well sometimes, like to understand what exactly is happening in the background of a particular code. So it's always advisable that whenever you're starting to code in very early stages, what you need to do is you sit with the computer, you sit with a notebook and pen. Then as you are making this whole code, you do it mathematically, right? Let's say you are involving some loops, you are involving some conditions, okay, and you are trying to, let's say you are yourself the computer and someone is giving you that commands, okay, you have this number 3, then add it 5, then minus this. So you do it mentally, you do it on the paper, and then try to match the results. In that way you'll be able to understand what exactly is happening behind the scenes. Okay, even that is quite important in terms of programming languages, if you want to understand more as to how this whole thing actually works. Right, so this is how you actually deal with complex numbers. So we have certain things, and yeah, so this is complex numbers. Now same goes for real numbers. If you want to convert this whole thing into real, right, so you have to do nothing, just it's quite straightforward. You just have to type real, okay, and you just have to type real, same thing. Okay, I think I have it as not complex. Okay, I understand. So basically this is the real function is what we'll use in another library, which is called Numpy. We'll be using that. So we'll be using the real function from there. So there's another important thing which I actually forgot to mention earlier, is whenever you want to understand whatever particular function is doing, okay, let's say you don't know that what sort of arguments that particular function takes, or what exactly does that function do. So you have to simply type the name of the function, let's say complex. You just have to type question mark, okay, and then should do shift plus enter. Now here's something important comes up, which is the documentation, or let's say doc strings, which means it will tell you what exactly that function is doing. So here you see it's written complex real equals to complex real equals to 0, imag equals to 0. What it does is it creates a complex number from a real part and an optional imaginary part, and this is equals to real plus image 1j, where image defaults to 0. Right, so this is how you can understand it if you sometimes forget, right? Sometimes it happens that you actually forget that what that function takes, and it happens a lot of times. Even you have practiced a lot, right? There are many libraries, there are many functions, and there are many things, and you forget what exactly is the argument of that, or what is the output of that particular function. So you don't have to do question mark, and then you'll see. So you see, it takes actually two arguments, okay, and it is saying here that it's an optional part, which is an imaginary. So imaginary is an optional part. So whenever you have these optional arguments, you don't have, it's not necessary that you have to put that, okay. It will work with other arguments as well, not necessarily with that particular argument, which is quite optional. So how do we use that? You have to just simply, let's say I don't use this thing, okay. So complex. Now it says that the first was real, so I'll just type real equals to 4. Then let's say it said imaginary. Let's say imaginary was, let's say, 10 raised to the power 10, or let's say 4, 3. And okay, let it be this thing. Okay, and it, let's say what exactly is Captain Kirk. I'll just print it. Okay, print Captain Kirk. I'll see. Okay, and it converted me into a complex number. Okay, so there are different ways in which you can define this thing. Also, it's not necessary for you to write this thing, real equals to. You can even remove this thing. It takes automatically that whatever that first argument is, it will take it automatically as a real part, and whatever the second argument is, it will take it as an imaginary part. Okay, it depends on what sort of programming you want to do. So I can do the same thing here. You'll receive the same result. So there's one question which says, can we do this programming in Google Collaboratory? Yes, definitely you can do it anywhere. I mean, it's totally up to you. Google Collaboratory is another open thing in which you can use this Jupyter Notebook online. You can upload your Jupyter Notebooks. You can upload your data sets, or you can even download that Jupyter Notebook as well for further use. So yeah, you can use Google Collaboratory as well. So are there any other further questions till now? I don't see any anyways, but okay. Okay, so there are no questions till now. Okay. So right, so this was about some basic data types. So I'll just summarize this thing basic, which is till now we have done integers, right? Integers, and we did floats. Now we have done complex numbers, right? Then what we did, okay, we did strings, right? With strings, right? So yeah, I think these were the basic data types that you have done till now, and we'll be using this further as we progress day to day. Okay. Now here at this point, I think it would be better if we take a minute to see if there are any further questions, because this lag might uh, remove this thing. So maybe if there are any questions, maybe you can post them down in the comment box. Okay, so I don't think that I see any questions, so maybe we'll just move on further. Okay, now comes a very interesting part, is importing libraries. Now here in Python or any other languages, we have so-called libraries in which there are inbuilt so many functions which are pre-coded for you all, for everyone. And what you have to do is you just simply have to call this library and import those functions into my Python notebook and then use them as per our convenience. Now those basic functions can include basic trigonometric functions such as sine, cosine, tan, inverse, or let's say inverse functions, logarithmic functions. Right? We have log, we have natural log, then we have hypergeometric functions, and we have all sort of scientific functions involved here. Right. So right now I'll be doing some simple functions. And the very basic library which comes included with every Python is this math library. So it's very easy to actually import a library. So what you have to do is you simply have to type import, okay, which you see comes in the dark bold phrase. So import math. Right? So right now we have imported this library called math. Now I want to see, let's say I want to import a very basic function, which is sine function. I hope everyone knows about the sine function. So how we can do is, so what you have to do is you simply first have to type the name of this library, which is math. You have to put a dot, and then the name of that function, which is sine, right? And then curly bracket, which means I have to give some um, arguments. Okay, so every time whenever I have imported my library by this phrase import math, I have to use math dot the name of that particular function. So let's say I want to find the value of sine 0. Right, now everyone know that sine 0 is actually 0. So let's just do math dot sine 0. It comes out to be 0. All right, so let's say I have 30. Now here it takes in radians. It takes in radians. We need to convert it into degrees. So what we'll do is np dot pi by 80. Okay, we have to multiply this so as to convert my units, right? So when I do this, okay, so what I did was not correct. So what I have to do is I have to first multiply this by pi by 80. So pi is basically 3.141, okay, divided by 180, and we get an approximate answer which is 0.4999. Now sine 30, which is sine 30 degrees, is basically 1 by 2, which is 0.5, and we should have received a 0.5, but what exactly happened is the value of pi that we have taken is just have just taken till 3 decimal places, right? And so that's why that we hit this particular issue. Fortunately, we have the pi as a value as a value imported in this particular library in math. So what we need to do is we need to use this pi function from this library as well. So what we'll do is math dot pi, right? And then you have to use this thing, and you'll get this answer, which is approximately 5, right? Which you say that it will be, around 12, 13 decimal places. So here it will give an approximate answer very close to this, which is 0.5, right? So this was the first usage of this function. Now there are different ways in which you can import libraries, import functions from libraries. So this was this one thing, which means that I'm importing this library as a whole, but I'm not importing the functions, okay, which would take up a lot of space into the memory of Python itself. So we don't want that as of now, because when we do huge computations, we want the memory to be clear so that it can compute with some huge numbers. So right now we will just do this basic thing. So let's say I want to import sine function from the math library, and in doing so we won't be needing every time we won't be needing to write math dot, right? So what we have to do is we have to type this thing from math import sine, right? Just like in English. So what this statement means, from math import sine. The simple English, when you put them into phrase, it means that from math just import this function, which is sine. And I do this, then I no longer require to call the math, this math dot library, because now it knows that I've already imported this function into my Python. So I just have to write sine, and do this thing, right? And then we go on doing with something like this. Now I can do same thing. I can import, let's say from math import pi. I can do the same thing. There are different functions. Let's say you have cos. So instead of writing this multiple times, you can write this thing from math import cos. You just have to put comma and then the name of the function. It's a cos, sine, log. Then you can have this exponentials, and you have this exponential. I have imported them all, and let's say now let's play with something like, let's say cos 30 degrees, not degrees, from radians to that. We have math.pi divided by 180 degrees. Oh, I don't need to put math dot again, right? Because we have already imported those functions. Cos 30, which is root 3 by 2, right? Uh, this is what we get, 0.8666. Now, if you want to see if this is root 3 by 2 or not, right? If you want to say whether it is root 3 by 2 or not, so there is another function in math which is used to calculate the square root. Instead of every time writing raised to the power 1 by 2, there is a function called sqrt, right? You have to import the square root, then you can do sqrt, and then you can just simply copy this number. Okay, what I'm trying to do, I'm trying to find if this is equals to root 3 by 2 or not. Okay, so root 3 over 2, this thing should be equal to this thing, right? And you see it is approximately same, only that the last digit differs by this thing. So this happens because here we have used pi, which is an approximate value, and here we have square root 3, and so there is only fractional difference, negligible, although which we can obviously neglect. So the values are quite similar. All right, we can do the same thing. Let's say 60 degrees. Now cos 60 is 1 by 2, and we get 0.511, 0.000. All right. So this was the very first step of using functions. You can use exponentials. You can, let's say, oops, apologies. Okay. You can use exp times, let's say 2. Get this particular number. You can write a very small number, let's say 0.0014. Get 1.00 some particular number, and so on. You can use all these functions. You can use logarithmic function, which is log. So let's say log of 10. No, log of 10 is something like 2.30t. So here it always takes natural log, right? So this is basically natural log value, which is lne, right? So that's why it's giving the value of e, which is 2.30 to something like that. So if you let's say put this value in log, then it should technically should be something like this. Okay, I did a mistake. Okay, yeah. Okay, so this was this number. I will take the anti-log of that, then I'll get this thing. So here we have logarithmic values. You can understand what exactly is happening behind the function. As to understand what exactly what type of arguments these functions take, you simply have to type question mark, and here it says. So here you can see that log x, and here what the base is they have taken is e, math.e, right? So you can change that base as well. So let's say I write log 10 and base equals to 10, right? Okay, it says that if the base not specified, returns the log to the given base. Log takes no keyword arguments. I think maybe it's saying this. Log takes no keyword arguments. Okay, so you don't have to put anything. You don't have to put any keyword to this particular argument. You just simply have to type the number, right? So log 10 base to the base 10. So this is what we get as 1. And earlier, by default, what it comes is to the base of e, right? ln e, which we say in intern, which is LNE. So you're saying, so someone is asking, is it for students? Yeah, it's for students. This coding camp is what you're referring to. It's for everyone. Okay, so we have log 10 over 10, right? So yeah, you can do all sort of computations. So right now, I guess we have used almost all the functions, I suppose. Yeah, so these are basic functions which you can use from math library, right? So it's just one library which you can use, but math library does not come with a large number of functions. This contains only some functions which are which are essential for basic computation. But sometimes what happens that you have to deal with heavy computations which involve some heavy functions which are not inbuilt in this library. So we use another library which is vastly used in every domain, which is called NumPy. Right. So for people who are using on Windows, they might install Anaconda. Okay, Anaconda is the distribution software for Python that they can install. So in that it comes inbuilt for Python for users who are using on their simple Ubuntu or Linux based system, and they might be using from command line or installed Jupyter Notebook using command line. They will have to install this particular library called NumPy using Python packaging software, which is pip. So you might have to install using pip this particular NumPy library. But for now, if you're using this online version, you don't have to use anything right now, right? So what you have to do is simply go import NumPy. Okay, and it's now imported the library. I can use same functions. Okay, NumPy has same function. Let's say cos numpy.cos, as I said, mentioned earlier 60.np. Okay, 60.numpy.py over 180, and it gives me the same answer. Right? I can write it with Sine as well, and it gives me the same answer. Right, 2 3 by 2, which is about this number. And let's say exponential, I can write it the same thing, numpy.xp. Then we have numpy.log. Okay, so here it does not have that base thing. It just have this numpy.log. So you can do the same thing. You can do the question mark thing again if you want to understand. If you want some help for this function, you can open the help menu, and by this you'll get a big thing, which means that right now in this NumPy version, NumPy version of log, it gives you more type of things to do with log thing. So what it says is it's natural logarithm element wise. So natural logarithm is the inverse of exponential function, blah blah blah, and it's base to e, right? And yeah, this is what you're going to do here. These are the different arguments which can be which you can give. Although these are optional, and it depends on what your function or what type of need you have. On that basis, you can change these arguments if there is need. But I suppose you will hardly need that, at least for now. Not at least for now, you won't need that. So okay, so now we have this NumPy library imported. Now I was telling about the different ways in importing libraries. Now I'm tired of writing NumPy every time. And let's say I want to, I don't want to write these things. I want to import each and every function of that particular library, which will take a huge amount of space. But still, I want to do that. So what you can do is you can simply do from NumPy. Okay, same thing, from NumPy import. Now for importing each and every function, you just have to write star. Star means it will import each and every function of this particular library. And I do this. So I no longer need to write this thing. It will keep on with this thing. Right? So NumPy has, let's say, so right now I did not import, let's say, log or exponential. I did not import that. I did not import exponential till now. So I can do this thing as well. Exponential of this particular number. I'll get some number. All right. So this was the basic thing for basic importing of libraries, right? So I mean, for those who might be thinking that this is actually sort of boring and on the first time basis might not consider to be that much interesting. We have interesting stuff coming up as soon as you're done with these basic handling of Python and basic handling of coding, so that you will be able to handle huge data sets, or able to plot some amazing things as well. So in our next in the next part, I'll be showing you how to do some basic plotting, making some beautiful plots using Python. And personally, I use Python as well a lot for my programming purposes, for computations, and mostly for plotting purposes. You have research papers, and you have to plot some publication quality plots, which are very highly graphical and sometimes very high quality. So you can use Python to actually generate those plots, right? So right now, for generating those plots, you have this library called Matplotlib. It also comes pre-installed, but for Ubuntu users, for Linux users, you have to install it using pip. So how you can do is you can simply import this thing as import Matplotlib, right? This is the main library, and the main plotting functions happens to be in a sub module of this library. So every library has these small modules within which there are small functions. So this module called pyplot, and I have this pyplot. Okay, now I'm doing another thing, which is as PLT. Now, what I just did here is I imported this whole library. Instead of calling a specific function, or instead of importing all the function, what I did is I won't be using this whole name, very big name, every time whenever I call a function. I rename this whole thing locally as PLT. So every time I will call a function, I will use PLT for this particular function. Okay, so that was another thing. Now, to plot something, you need a data, right? So for this, you need to generate some data. Now, generating the data requires the knowledge of lists and arrays. So we have these things called lists and arrays. So arrays are basically set of numbers, use numbers, which can be in any which can have any sort of dimension, or in terms of programming language, it's a shape. Dimension as in it can be 3 cross 3 something matrix sort of thing. It can be 3 cross 1 matrix, 5 cross 1 matrix, or 2 cross 2 matrix, anything like that. So that can be an array, or it can even be a single column or a single row array. List, on the other hand, is basically just one dimensional thing, and in which you can input some stuff, you can write some stuff into it, you can take out some stuff from it. So I don't know if I'll have some time, I'll also include slicing, which is a quite important tool when you try to slice a list, which means you want some specific data of this particular data set, right? You want to slice it, which means you do not require it. So that will be coming to it later. So here I'll do some another thing, which is import numpy as np. Now these two iterations, these two iterations are very important, because sometimes it happens that it depends on people to people that what sort of convention they follow. And globally, normally people use these things. Like for numpy, they rename it as np, and for matplotlib.pyplot they rename it as plt, which comes in quite handy, because different people use different things, but mostly they use this thing. Like for example, tomorrow Professor Niraj will be taking the session, and he may have some different convention to follow. So for now, we'll be using import numpy as np. So just a heads up if you get confused for the tomorrow's session. So you can rename it as anything as you like. I can rename it as my name. This is Saurabh, right? I can rename it as my name, and it will definitely work. But for now, I'll just use np. Right. Now, let's say I want to I have some function, let's say x, and I want to generate huge set of numbers. Let's say I want to generate numbers from 0 to 3 pi. Let's say I'll be plotting some basic, basic sine function, and I want to generate a list of numbers from 0 to 3 pi. So how will I do that? I'll use a function called linspace of Python. Okay, linspace, which is np dot linspace. The linspace function, what it does is it creates a set of numbers from the starting point, from the initial point, and how many numbers you want it. So it takes 3 arguments, right? So the first is the start, that from where you want to start. Let's say I want to start from 0. So where you want to end. Let's say I want to end it on 2 pi. Now 2 star np dot pi. Okay, just follow me here, and then we have how many numbers you want. Let's say I want let's say how many numbers. Let's say I want 500 numbers. Okay, so what it will do is it will create 500 numbers with equal spaces from 0 to 2 pi. That's why its name is linspace, which is linear space, right? Equal spaces between numbers. So I created an array of numbers, so I can see it here as well. Let's say I'll just put it X, and I see a list of numbers. Okay, it says array, and I see how many, around 500 numbers have been generated from 0 to 2 pi. 2 pi 6.28 something, right? But I don't want to see this. It's huge list, right? Now I want to plot a sine function. So what I'll do is np dot sine and x. So what I did here is quite simple. Is I simply generated a list of numbers, right? And I calculated the sign of those functions. I calculated the sign of those functions at each and every point that I just created to plot it, right? So now I have x, now I have y. To plot it, I have to use a plot function of this matplotlib dot pyplot module, plt dot right space. The first argument that I need to see is x, which is the x-axis values, right? And then y, which is the y-axis value. So x is in the x-axis values will come my numbers which I just generated. Y-axis shows me the sign of this particular function. So what I'll do is something like this. And this is a basic plot. So this is the basic pattern which the sign follows. So here you will see that it has the values go from -1 to 1, which is basic amplitude, right? Now here the amplitude is 1. Now amplitude is basically what? The coefficient of this function, which is 1, right? So I can change the coefficient of this particular number. What I can do is I can do 3 star np dot. Now I change the amplitude to 3, right? And in a similar way I can do. Now sometimes what will happen that for people this plot might not show. Okay, it will just show this thing and it will not show this plot. So what you will have to do, you have to introduce an extra command, which is plt.show, and then parentheses, just like this. Okay, so you have to put in this extra command as well. So I'll just do that, and voila, I have a sine plot from -3 from 0 to 2 pi with an amplitude of 3, as we see here, right? So this is a very basic simple plot of sine. I can play it more. Let's say I want to change the frequency, right? So what I'll do is changing the frequency. I'll simply multiply a number with my argument of that sine. If you understand the sine function, right? So let's make it 5. Here the frequency changed. The frequency actually increased from 1 to 5. So it is now occurring 5 times between this particular 0 to 2 pi interval. All right. Now, if I want to change the phase of this function, let's say it's pi by 2 ahead, right? Now pi by 2 np dot pi by 2. Np dot pi by 2. Right. So it means, so just try to follow me here. This is nothing but it is a basic sine function, as you might have studied in your 10th grade, in your 12th grade. So the coefficient of the sine number gives me the amplitude. The basic argument of this sine function gives me the frequency of this thing times the number, frequency times the number, which is omega x plus phi. Now phi is there. Here is the phase, that from where it is actually initially starting. So here what it'll show is it starts with the initial value of pi by 2. So it starts from up, right, with a difference of pi by 2. So this is how it's going. Let's make it much more interesting. Now let's introduce a cos function. So np.cos, let's make the frequency same, 5 times x. Let's remove this thing. Let's make the phase same from both of these functions. And let's even make the amplitude same, just for the sake of understanding, right? Now I want to show both of these functions in one plot. So how I can do that is you just have to write it again, plt.plot, same thing, x times, but now it will be z, right? Because this is another function. You just have to write this thing and you just have to show this thing. So now we see two different plots. Now you have the basic understanding. So obviously the one starting from 0, without any phase, it will start from 0. This is the sine function. This is the cos function, right? But let's say any new person want to understand. Okay, you want to use this plot somewhere else. So you want to put a legend, okay, legend, or it's some sort of labeling to this plotting. So what you can do is you can label these plots. So how you can do that? It's quite simple as well. So what you have to do in this first thing, you simply have to type a keyword. So put a comma and you have to put it label equals to then inverted commas, which comes strings, right? So here my first plot, which is y, it is a sine plot, right? So I'll write sine. And here in the second one, it is label equals to cos, right? I hope you are able to follow this thing. It's not that tricky. So the first argument is the x-axis, second argument is the y-axis, third third is something else, but I want to label it, so I'm using this keyword, which is label, right? All right. So label equals to sine, label equals to cos. Now I want to show this label in this particular plot. So how will I show that? I will use a command which is legend, plt.legend. This is legend, right? So what I'll see here, I'll see a legend popped up right here, which tells me this blue line is sine, this orange line is cos. All right, you can play with this further. What you can do is you can simply go to you can modify a whole lot of things in the plot. You just have to go plt.plot, put a question mark, a help menu will appear, and you will see that what type of arguments it takes. Like just scroll down and you'll see parameters that it takes, data, and all sort of things. Here is the list of all the properties that it can take. You just have to practice and then you can plot all these things, right? So this was the basic plotting module. So at this moment I would like to take a stop for a minute maybe and see if there are any questions. If there are any questions, I'll be happy to take them right now. So let's take a 2-minute break maybe. We'll start again at 3:25. So I'm not seeing any questions right now. Let me see if there are more questions. Please feel free to ask any sort of questions which you might be facing right now. It can be anything. I'll be happy to take them. All right. I don't suppose that there are any further questions. So, okay, maybe we'll just go on. Okay, so so this was basic plotting module. Although I had something interesting to show or maybe to plot, which I guess you guys can do as well. So here it's very basic thing, which I think maybe you can do it. So what we are doing here is, no need to focus on this. So first I created this simple array of values, which is x is equal to 0 to 2 pi or 1000 set of values. Created a sine function, let's say as y1. All right, so we have y1 as np dot sine x, y2 as cos x. Now I want to plot them into different plots, right? I want to plot them into different plots. So what I'll do is I'll create a subplot. So in Python, what we have is a the subplot. So what I'll do is I'll do something like this. So this plt.subplots, I'll call this function plt.subplots, in which number of rows, it's like one row and two columns, and it takes and it gives an two as in two outputs, which is fig and axis line, right? So I'll assign those outputs to these two variables, and I'll be using these ax to basically plot them onto, right? So here what you'll see is what you see here. So ax0. So ax. So I'm using this square brackets here to assign, the which place it is occurring at right now. So you can consider it as a matrix if you understand it. So matrix is nothing but sort of tiles placed into in some square boxes, or let's say some elements, and you just simply have to look over it and assign some places to those tiles. So here we have one column, one row and two column. So this tells me this is the first figure, ax0. So in Python, the counting always starts from 0. This is very important to note, because sometimes it happens that there are languages where the counting starts from 1, but in Python the first number is 0. So if you say tell me the first 10 numbers in Python, so it won't start from 1 to 10, it will start from 0 to 9, right? So that's how it happens in Python. So the first number is 0, so ax0 dot plot. Then I can remove these things for now, right? So ax0 dot plot, subplots, it's like the same module. So x dot plot x comma y1, then x dot plot x comma y2. Now don't get very confused with these terms. For the sake of understanding right now, you just need to understand what this is. And I just plot it, and here I see that the first one plotted with sine, and the second one plotted with cos. I can increase the interval. Let's say I want to make it to an interval of, let's say, 10 pi, right? So I run these commands again, run these cells again. So now it's showing me from 0 to 10 pi, which is somewhat to 31, something like that, right? So in this way you can show two different functions in two different plots. Earlier we showed it into one same function. Right now we shown into different functions. You can label them as well. So here I can label it as, let's say, first one was sine. Again, label sine. Label equals to, let's say, cos, right? Then what you have to do is you have to ax dot 0 dot legend. So the same thing. Oops. Okay, and so whenever you will assign this ax0, so whenever you'll be doing anything related to this first plot, you have to assign this thing first, right, for this subplot. So I have to do the same thing for the first one. So ax bracket 1 dot legend, it will show me the legend for this plot, right? Now legends, right now we did not need to use this, because we know that the first plot is sine plot. So instead we would rather need a title, right? So what we can do it here is we can just simply remove these labels, and instead we can put some titles. So to put so here in subplots, it's a different method for putting up titles as compared to here. So right now, if you want to put a title in this plot, one plot without the usage of subplots. So what you'll have to do is plt.title. Right, you just have to use title, plt.title, put the name of title, let's say sine cos function. Right. So it showed me some error. Okay. So here it showed me error as x and y must have a same first dimension, but as shapes 1000 and 500. Meaning that when I'm plotting these x and y, they do not have the same element size. Right. You cannot plot with x values as suppose 10 values and y as let's say 100. In this case, it's 1000. It is 500. Right. You need equal number of elements. So because here xi ran with 500 and in this thing it ran with 1000, so it's taking the recent one, so it overwrite this earlier. So now I have to run this again. Now it shows me again. So instead I'll just simply remove this label. Oh, let it be. And here I can use a title as well. Regularly you can put labels to the x-axis, to the y-axis by using this command plt.x label. Right, x label is let's say x-axis, x-axis, plt dot y label. You can do it with let's say y-axis. All right. So here I have x-axis and y-axis. You can see. You can change the font size. You can just simply go to this comma. You can write font size. You can change the font size as well. For the title as well, you just have to write font size equals to 16, and same as for this thing, font size equals to 16. You can change the font size as well. Right? Same goes for the title. You can change the font size for title as well. Font size equals to 16. Right? It seems quite straightforward. Okay, let me just let it remain here if anyone is doing it with me right now. All right. So coming back to here, how we'll put the title in this subplot. So for the subplot, what you have to do is you cannot just directly put ax dot title. No, that's not the way here in subplot. For now, you have to do is put this thing set underscore title. So you have to use this keyword, this particular function for putting title into this subplot. So set underscore title. Then you can just simply put, let's say, this is a sine function, right? Sine function. This is the first one. And remember, I have written this thing. I'll just remove this thing. X0, right? Now I have to put it for first plot, which is this second plot. So ax dot set underscore title is the cosine function. Okay, maybe there is some. Okay. Again, I have to run these because I think it would have same thing. Yeah. So here we have here we get the same thing, which is the sine function. You see the title here, then you can see the cosine function, which is the title of the second plot. You can set the labels in a similar way. You have set the title ax0 dot set underscore x label. You can write it as x-axis. Right. Similarly, for the first one, you can write it as set underscore x label. X-axis. Right. Now, if you want to write, let's say, for the y-axis, what you have to do is ax0 dot set underscore y label, which let's say is here the sine function, right? Let's say sine of x. And for the first one, it was, I mean, the second plot, it's the cosine function. So I'll just write cos x. So here it seems that the plot needs some refiguring. So I need to change the figure size, but somehow we have this thing. So at least it's working. It's showing that it's working. Here we have y-axis, we have sine x. On the x-axis, we have x-axis. Similar here, x we have x, and the y we have cos x. So we can change this figure size as well, and it's quite simple to do that. So how you can do is you can simply go to plt dot. Let's say you can do it here as well. In the subplots of command, you have to write another command, is fixed size equals to, and then parenthesis again, and then here you have to define the x and y dimensions, right? So let's say the x dimension is right now around 10 units, and y dimension y is around 7 units. So this came at something like this. So some of the y dimensions are very much, and 7 x dimensions are quite less. Let's say I'll just reduce it to 7 for the reduce. So I'll do it something like this. Okay, it increased more. I needed a much bigger number. Let's say 14. All right, this seems very neat. So here we have done some basic things. So here we have plotted, sine function into a different plot, and cosine function into a different plot as two different plots, and which using this subplots function of Matplotlib library. Right. So this is how you can do this thing. Some basic plotting things using Python, and you can make your plots much more beautiful, by changing the colors. So here you can change the colors. You can simply go comma, and you just have to put inverted commas, nothing else, and put the code for that particular color. So here in Python, in Matplotlib, so there is some letters which are defined for the coloring code. So for red it is R, for black it's K, for blue it's blue. So let's say I want to do the first plot as K, which is black, and for the second one, comma, and inverted commas, let's say second plot should be in red. So I just did red. So here we have black and red. You can change the colors as per you like. You can put first one as cyan color. This is first one, or you can put it as lime, which is lime color. You can put it magenta. You can put red. It's totally up to you. You just have to see the documentation of this Matplotlib library to access what are the different keywords or what are the different functions for these things. Like you can simply go to Google and type Matplotlib, and Matplotlib colors. Okay, you can go to simple list colors, and you can simply go to a list of named colors, and here you will see the list of basic color. These are the base colors, which is B, G, R, C, M, Y, K, W. Right. So there are different colors. See, there's a whole wide range of colors which have been used: white snow, white smoke, and all these other stuff. I can use this dark magenta, maybe. Then this carrot blue. So let's use this. Let's say dark magenta. There's another carrot blue. Here we have some more beautiful plots. Right. It seems very interesting, I suppose, and seems very colorful. So this is how we can actually use this thing. So I hope you people are able to grasp or understand this as I follow it, and as you follow it, based on my pace and based on the speed at which I'm going. I hope everyone is comfortable. So here you can use different plots and different functions to understand different plotting schemes for Python. So let's make this more interesting. So as a different exercise today, I thought to introduce you to functions. So here what we'll do is we can define our own function in Python based on whatever you want to introduce to. So let's say I'll make a function of my own. let's say I'll make a function of sync function. So for people who don't know, I don't know if you know the sync function. So sync function is basically sin x over x, right? So sync function is called sin x over x. So let's create a simple function of for sync. So def. So for whenever you want to make a function, it starts always with def, which is define. Def space whatever the name of function you want to keep it. Let's say sinc brackets, and here goes the number of arguments, or let's say the parameters on which your function will be dependent. So right now my function will be dependent on only one thing, which is the values itself, so which is x, and then you have to write it as colons and then enter. And after entering, you have to give a tabular space. In Python, it's absolutely necessary that you understand the value of indentation, because unlike C++, here Python takes care of indents or spaces to understand which things come into that particular function or into that loop or into that particular statement. In C++, this thing happens with curly braces, so you have to always put curly braces for this thing. But here it takes care of by spaces, or let's say indentation. So here we have sync x, and we're a tabular space. Then let's define a variable. Let's say a as np dot sin x divided by x. Now this function has to return something to us. So return a. So now this function is actually returning the value of a. Again, let's follow it. For defining a function, you have to write def name of this function, whatever you want to name it, aside from already which has been taken by Python, like int, or let's say complex, or let's say this sign or something like that. You have to make sure that you don't use those literals which have already been used by Python, because that would be very confusing and won't allow you to do so. So right now you have to define the same function, define it, make it something like this, any function, anything you want to, then return that a. Right now I already defined x here. All right, now my first one was sine, second one was cos. Let's make it a third one, which is sin, right? So SINC and x, which is the argument. Now coincidentally, x here and x here is same. Let's change this value. Let's make it capital X. Okay, so capital X and small x are different. So here small x is this value, and here sync of capital X. Oh, sorry, small x. So here whatever value I'm inputting, this will be regarded as this thing and will compute this value, and hence returning the value of sin x over x, right? And this is the y3 value. Okay, so it says that invalid value encountered in true divide, which means that my value is starting from 0. So x sin x, which is sin 0, divided by 0, so it's coming divided by 0. So I have to use very small fraction of deviation from 0. So I'll just use 0.001. Although we don't need to worry, because it might have disregarded that particular first value, but still it's better for us to choose a value which is near to 0 but not exactly 0. That has been solved. Now here, let's say I wanted to introduce another plot. I have 2 plots already. Let's say I want to make 3 plots. So instead of adding another thing, we can simply use third 3 columns. So I'll just n balls equals to 3. I will again here. So here my third plot will be ax2 dot plot x comma y3. Let's change this color to blue. All right, and let's name it as ax. Okay, let's let it be for now. All right, so now you see the third function here we have successfully plotted is a sync function. Sync function is just a sin x over x, which is damped function, right? So it's actually damped and it will soon end at some later value. Right, so this is what we have as another function. And so here we learned how to define a function and then how to plot it. So I can I can I can add the title as well, ax2 or ax2 underscore title, sync function. I can put the x labels as well, ax, oops, ax0 dot set underscore x label, which says x-axis, and here ax2. So I'm giving a space, between the codes so that it would look neat to us. It's not necessary. So yeah, set underscore y label. This is the sync function, SINC, sync of it. And here we have successfully plotted this thing, right? So this is one of the most important things that we need to understand, and something which is quite graphically beautiful, something very artistic. And here you can do this. Let's increase the size of this thing. Let's make it 17. Let's increase the size 4. Now it's looking much better. So here I've increased the size of this width and decrease the height of this thing. So I think now it's better. And okay, let's make this much more beautiful. How we can do it? I can add grids, right? I can add gridding to these things, to these plots. How I can do that? I can do it with a simple command. So ax0 dot grid. You just have to write grid, and in the first one you see there will be a grid appeared, right? So you can add grids to all the plots. Ax1 dot grid, ax2 dot grid, similar to that. Right? So yeah, so now I have added the grids, and you can see in all the plots I have grids. Now it's looking much better. Now okay, let's make it more better. So instead of having these grids, let's make the grid a bit more transparent, so that you can see the curve much better. So for transparent, there is this argument called alpha in the grid. So let's set the value of alpha. So alpha stands for between from 0 to 1, where 0 being uh, with 0 being the less transparent and 1 being most transparent. So let's set it to 0.5. Alpha equals to 0.5. Alpha equals to 0.5. And here you see that it has become a bit more transparent. And now it looks much better. Right? I'm guessing you can see this thing. Or maybe there is some internet issue with the quality. Right? So here we have plotted the functions, and we have seen how to make it much more beautiful, change the colors. I can change the width of these lines as well. These plots that we have, I can change the width of these lines as well. So using a simple command in the plot itself, and the plot you have to do is LW, which stands for line width, equals to, let's make it 0.9. Right? Let's make it 0.9. LW equals to 0.9. Same with this thing. LW equals to 0.9. Now here you see that we have decreased the width of these lines as well. So you can use this command as well. Let's make it thicker. You can make it thicker as well. Let's say first one is around 3. This is 0.9. Let's make it 2. So here we have, this is much more thicker, this was less thicker, and this is a bit more thicker than the first one. So here in this way you can simply plot these things. You can create complex functions. You can do these things. So meanwhile, what you can do is, as an exercise, as a sort of a homework, maybe, I don't know, what you can do is you can try to define a function. Let's say you can define Planck's law, maybe. To define Planck's law, then generate the values, plot a Planck's law or function, maybe in terms of frequency or temperature, whatever suits you, and you can try to do that at some particular temperature, and that would be a quite nice exercise. Maybe next time that you guys will be joining us. So I think that that would be great. So I think for now we'll take a stop now, and so till now, so today what we have done is we understood about different types of data types, integers and float numbers, complex numbers, strings, real numbers. Then we understood about the libraries, different types of libraries that we have right now. We are using Numpy for basic numerical computation. Then we are using Matplotlib for plotting, as a plotting module for plotting stuff. Then we defined functions. We define our own functions and using simple definitions. Then learned about basic arrays, and then basic plotting and some beautiful plotting using Matplotlib. So yeah, so right now I just hope that if there are any questions, I'll be willing to take them, and maybe stop here. If there are any questions, you can simply put it in the comment box right now. All right, I see no queries. Anyone else? If anyone has any particular queries? All right, I don't see any queries till now. So let's see. I guess we have some time as well right now, maybe a few minutes. So are there any questions? If anyone wants to know how they can install Python in their own system, maybe I could help them out right now. Or let me just take a quick session on that as well. If you want to install Python in your system. So for those who are interested in installing Python on the system, which is, let's say, Windows. So Windows or Linux or Mac or anything, you simply have to go to Anaconda. I mean, this is the most simplest thing. Let's type in Anaconda Python. All right, on Google. Then you'll visit this website called main individual section. Go to the official website of Anaconda. It's a Python distribution software in which Python comes pre-installed. So you simply have to go to this particular website, and then you have to scroll down, or maybe here itself you'll see different installers. Like for Mac, for myself, it will show me the Mac version. Here I can download it. For Windows, for Apple, for Ubuntu, for Linux, you can download your own versions and install it. So in this way you can install Anaconda in your laptop. So once Anaconda is installed, you can simply go on to the environment section into whenever you open Anaconda, and then you will see Jupyter Notebook. Okay, there'll be two different versions. One will be Jupyter Notebook, and one will be Jupyter Lab. So these are very similar to each other. Yet what we use is a Jupyter Notebook. So you can simply open the Jupyter Notebook and start working, start playing on with these things, and I hope you'll be having fun with these things. So this is a very basic way. If you want to install Anaconda, it's somewhat around 500 megabytes or something like that, maybe. But if you're not interested in installing this Anaconda, you can simply go to Google Colab. All right, you can just type in Google Colab. Then you can open this thing. This is a cloud version of Google, and here you can simply use Google Notebook, this Jupyter Notebook online. There's no need to install for you. There's no need for you to install Jupyter Notebook. You can simply go, click on New Notebook, and then there'll be a new notebook which will open for you. So due to this internet connection, it might take a while, but so yeah. So here you'll see this is a very similar version. So you can do the same thing. You don't need to worry of installing any libraries or doing any stuff. You can just simply start on importing, like starting importing now as np importing. So the first code is generally uh, importing the libraries. Usually, the first line of code is always importing those libraries. So we libraries, then you can simply start on working on whatever you want to work on. Let's say np.linspace 0 to 2, say 100 values, and then so on, so on, so on. All right. So you have to see that first. It will start here once it says connected, which means now the compiler is working. So here it shows me error, which says invalid syntax. You have to take care of syntax as well, because syntax is one of the most important things. If you don't know that what exactly to type or how exactly to type, just go on and search Google. So here I have to import matplot.library as PLT, and it has successfully been installed. Then I have to go x is equals to linspace. Then it's uh, now I can simply plt.plot x. I can do this thing, and it will plot me a straight line right from 0 to 2, which is obviously like this. And yeah, so this is how we go on. So for those who don't want to install, don't want to spend more time in installing and searching different sources how to use Python, you can simply use Google Colab, which is much easier, much faster, and better. A Google Colab takes time. You can also, there's another alternative. Instead of Google, you can go to Kaggle. Right? Kaggle is another very similar version of Google Colab. So you can go to this Kaggle website, kaggle.com, and in here you can start your own Jupyter Notebook as well. This will make your life very much easier once you understand Python and Python, and then you can use it into different versions of astronomy. So today it was mostly all about understanding basic coding and understanding programming languages. From tomorrow onwards, we'll more into the astronomy domain, because for now, because those 2 days will be based on today itself. So it's imperative that you understand basics and then jump on to some other stuff. So tomorrow, Professor Niroj uh, will be taking some sessions on basic, pulsar stuff, and some basic stuff usage of Numpy and Matplotlib, and using SciPy library, which is quite important to use whenever you are interested. And he'll be taking into basic stuff as Fourier transforms, which I think I hope most of you are already familiar with, so that you'd be able to uh, uh, make some sense in the context. So yeah, I think that's enough from my side. And yeah, if there are any questions, I'd be still happy to help and take anything right now. Okay, so I suppose right now we do not have any questions, so now hand over to Rena, ma'am.
Yeah, so I think Saurabh, for today's session, we'll just have a wrap up. I don't think there is some questions because most of the 3-4 questions are in the chat box. You already clear all that doubt during the session.
Yeah.
So we'll have a wrap up now, and tomorrow, same time from 2 to 4, we'll be meeting again for the continuation of this code camp. So thank you
Yeah,
for
definitely.
now. Thank you everyone for joining in. We really look forward to see you again tomorrow. Thank you, Saurabh.
Thank you so much. Thank you, ma'am.